Vectors. This is another thing new in this class. We are going to use vectors to represent different properties. They're not really something completely new. It's the quantities we know before, but we're going to represent them in a slightly different way. So I'm going to help you make the connections. We're going to introduce what a vector really is. And the second thing is really important. What's the positive and negative values for a vector? If you know that, you're going to be so clear with solving a lot of problems. And then we're going to give examples. First of all, when we make measurements, right? So for example, there's a dog that can run to the right, can run to the left. What we actually do is we just create what we call a coordinate system. When the dog runs to the right, I call it its displacement is positive, to the left is negative. As much as you know, positive is such a good word, right? Negative is a bad word. But in physics, positive and negative, they're both neutral. They don't really represent anything more than going to one direction versus going to another direction. So the coordinate system, as a matter of fact, is what people think of with their head. Coordinate systems don't exist. You never see a coordinate system falling off a tree, or you never hit your head on the coordinate system, right? So coordinate system is what people created with their mind. That's a way for us to keep track the direction of motion. See, for example, a dog can move that way. So what is a vector exactly? That sounds like a little bit so scary. Okay, so vector is really a normal property, a normal value we have. The value of a property, we call it a magnitude. Magnitude sounds like a really scary word, but magnitude really means the numerical quantity of a property. And plus direction. So vector basically tells you not only the quantity, but also tells you a direction. So that's vector. So for example, if a student drives to the east 20 miles in the morning, and the displacement we call positive 20 miles. Positive has nothing to do with positive psychology or positive attitude or positive anything. It is absolutely neutral here. Here, positive means direction. Okay, secondly, the student then drives west 20 miles in the afternoon. What is the displacement? We call it negative 20 miles. Okay, please do not hate the negative sign because negative here only means direction. And so what's the total displacement? Okay, as a matter of fact, a positive plus a negative is 0. And they say like, oh my gosh, driving all that much, it's 0 displacement. When we speak about displacement, that's what it means by definition. Then you might ask, why positive to the east? Can I use the other way? Yes, you can. As long as you are consistent with yourself, you're free to choose for the positive to represent any direction. Positive can mean east, can mean west, can mean up, can mean down, can mean forward, can mean backward. So in physics, the coordinate system, remember, is how people created in their mind, use as a reference to keep track of motion. So you have all the freedom to choose your coordinate system. Sometimes we use, for example, up to represent a positive direction, and that's just a convenient way. So I want you to be consistent. Displacement can be positive, negative because they're vectors. So if an object moves upwards, the ball is thrown up, the displacement is positive 2. If a ball falls down, the displacement is negative 2. If a ball goes right up and then falls right down again to the original position, then the total displacement is 0. So this is what we mean. Displacement is a vector. Can be positive, can be negative, can be 0. Velocity is also a vector. 25 miles per hour to the east, we call it positive. If we call that positive, then west is negative. So see, velocity can be positive, can be negative. Another example, if a tennis ball hits 10 meters per second toward a wall, and then the velocity, we call it 10 meters per second. We just name that the direction we call positive. If we use that reference system, then the tennis ball will hit the wall and rebound with 8 meters per second, slightly slower. What is the velocity? The velocity is negative 8 meters per second. Negative just means the direction is opposite to what we call the positive direction. Okay, so what is the change of velocity? Change of velocity by definition is always the final velocity minus the initial velocity. In this case, it's a negative 18. Remember, it's 18, not 2. Although it goes from 10 to 8, the change is not 2, it's 18 because velocity is a vector, and vector has positive or negative signs. So when we add or subtract them, we need to pay attention to the signs. So in this case, the negative means what? Means the velocity decreased 18 meters per second. Another example is that force is also a vector, and it can be positive, can be negative. Newton's 5 Newton, if you pull it up, the force is 5 Newton positive. So if we name up to be positive, then down would be negative. So if 5 Newton is pushing down force, that's a negative 5 Newtons. So you see force can be positive, negative. Again, this has nothing to do with attitude, has nothing to do with positive energy or positive anything. Remember, positive or negative signs in physics represent what? Direction. In summary, a vector is a property that we add a direction to it. That's what we call a vector. What does positive and negative mean? Positive and negative represent direction. In the reference system, we call it coordinate system. And we had these examples. We looked at different displacement, velocity, force, and also we're going to learn about acceleration. So these are all vectors.